friends. This is episode number 32 of the Game Audio Vlog, and we're going to walk you through, we're going to walk you through, who else is here? I'm going to walk you through how I've made Rtpcs in Wwise for the player ship. So I'm going to do things not the normal way in terms of walking you through a PowerPoint slideshow with some pictures and all of that. I'm going to actually click through all of my stuff in Wwise here because it gets a little bit complicated and you got to take a minute to wrap your mind around it. So before I get, I'm just going to go right into it. I've got Wwise here open. I'm going to go to the game syncs, and then here are 3 game syncs that we're going to talk about. Within, of course, the game parameters, game syncs are the things that talk between Wwise and Unity or Unreal, or I guess whatever you're working in. And each of the game syncs determines the outline of the Rtpc, I guess, is the easiest way to say it. So if I click player panning here, I get a range of values that I can deliver to the Rtpc. So it can be a minimum of a negative 3.12 here, or a max of 3.12 here. What this is describing is, in this case, for player panning, is the far left, as you can see my mouse cursor here, or the far right side of the screen. So if I remember correctly, the minimum value, and this would make the most sense, is that the minimum value is your far left, because it's negative. Think of a left-right, up-down coordinate plane here. 0 would always be right here, or at least negative would always be to the left. And then your max value is going to be your far right side of the screen here. So if I have the player's ship and he is in the default position of 0, he's going to be in the center of your screen. And then if he goes all the way to the left, you're going to have negative 3.12. And if you go all the way to the right, you're going to have positive 3.12. So you're going to flow between negative and positive 3.12 with a default center value of 0. So this is how I will get that value from Unity, and then we'll feed that value as it exists to the player panning game sync, which then the Rtpc within Wwise will read that and automate, essentially, for lack of a better term, what our sound sounds like based off of all of these numbers. So again, the way that works is there is a value, there's an X value for your ship within Unity. All we have to do is extract that, give it to Wwise, which is handled by the game sync here, the player panning game sync, which is then used within the sound and the event that we're actually doing. So I'm going to walk you through that here in Wwise. So let's go to the code. So here in the code, you're going to see, and we'll do this 3 times for each Rtpc so you kind of get an idea of what we're doing here. So void fixed update is our function, and it says fixed update is called 1 per specific time, which I actually have no idea what that is trying to describe to me. In the note, that's not a great note for me. But essentially, we've got stuff here that, this highlighted code right here is the code that existed before I added all the rest of this stuff. So it's getting our velocity, which equals movement times speed here, and you have a new movement vector. I don't know what the heck a vector is, but I don't need to know for the case that I'm an audio guy. For this, at least this specific thing, this is not knowledge that I need to know what it is, but you can tell that move horizontal and move vertical are values here that are being used to describe movement, right? You don't need to be a rocket scientist or even a coder to figure out at least vaguely what's going on here. This says put them in vector to variable xy, right? So you have an idea, there's a variable, it's describing xy. So you could tell that movement is being done here in the function. So what I did, again, was added the Rtpc values for movement around this function. And it works just fine. In this case, we're going to talk about player panning. So again, we've talked about setting Rtpc values before, but I'm going to describe it again for you. AK sound engine equals Wwise. So Wwise is the AK sound engine. AK being audio kinetic. AK sound engine dot set Rtpc value. In plain English, this means, hey Wwise, set the value of the Rtpc to what? So then the Rtpc we're working on is player panning, which is named right there. And then if I change the name of player panning here, I've got to change it here. Otherwise it won't work. These two things need to correspond to each other. And then we're pulling from Unity, from the game itself, transform.position.x, which transform.position.x is, hey, give me the current x coordinate value of my game object. So in this case, the ship, I need the x coordinate, the left-right coordinate of where the heck my ship is. And then feed that to the player panning RTPC. Set the RTPC value of player panning to the position, the x coordinate position of my ship. And then we go back into Wwise. You see again, player panning. It can only be one of these values, which I've already tested in the game, which I used a statement called debug.log, which in this case, I'll just type it on the screen so you can see what it would look like. Debug.log, and then we want transform.position.x, right? So that would spit out this value of either up to -3.12 or 3.12, depending on what side of the screen you wanted. And if you wanted to make it a little bit more humanly readable, you could go, hey, this is the x value. And then you need a little bit of space there, and you need a plus there. This will put the text, hey, this is the x value with a dash and then a space, because this plus doesn't actually add a space to transform.position.x. So when this feeds out in your in the code, in the game, whatever I'm trying to say, once you hit play and this spits out a value for you, it'll look like, hey, this is the x value. Whoa, matrix 4x4. The x value, and then it'll be like -3.12, right? It'll look like that. So I'm going to get rid of all that stuff, otherwise my game will not work anymore. Save it. Alright, so back in Wwise, this is where we actually do this. We go into audio, and then I want the player engine. I double click it, and we're going to go to positioning. You want 2D, enable panner, and then I think I hit edit. No, I didn't. RTPC, that's it. There we go. It's an RTPC, that's what we've been talking about. But this is a good point. You want to make sure that 2D is enabled, not 3D, because it's not a 3D game. Though if you wanted to do 3D for a 3D game, that's how you do it. Your center percentage is 0, and then enable panner is turned on. Your RTPC value, again, this is the RTPC tab for the entire sound. It's not the RTPC for any effects or anything like that. It's the entire sound. Pan left, right, 2D, player panning, and then I haven't actually even panned it all the way. I wanted up to about 75%, and then up to 75% here. So this would be, if I turn the sound on, let me put headphones on so I can actually hear what I'm doing. I can't hear myself, so I don't turn headphones on generally, or I don't put my headphones on generally. But let's see, if I hit play, what happens here. Okay, so we've got playing, that's center. Then the sound moves all the way to the left. Then it moves all the way to the right. Magic. See, or most of the way, one way or the other. If you're wearing headphones, this would be a very great example. Okay, so that's how that works. And when you hook the game up to Wwise and then the sound engine is running, you will actually see that working. And you're hearing a very low rumble for the sound engine, or for the engine of the player, because the RTPC is, for the player engine, is built into the effects. So we're going to actually cover that now. Game syncs again. Player ship movement. What I'm trying to do with player ship movement is add a little bit of acceleration velocity to the engine. So if the player moves up, down, left, or right, I want to give you a sense of movement. I don't want the engine to sound the exact same. But at the same time, when the game is happening, the player moves only a little bit up, down, left, or right at any given time. The acceleration of the ship doesn't continue. The ship doesn't continue moving in one direction. It stops. It slows down. So I just wanted to add a little bit of acceleration to just add a different bit of variance to the engine. So my minimum value is -2, and my max value is 2. Again, this will describe the up, down, and left and right. So going back into code, this I think is the complicated one. So here I want float move horizontal equals input.getAxis horizontal. float.moveVertical equals input.getAxis vertical. I don't remember if this was coded before if I coded it or not. I think it was coded by the programmer. I don't know that that's something I would have done, because it's also used on the vector, so that makes sense. So we've already got a move horizontal and a move vertical based off your input. So the user input, and then it gets the axis of the input, which is horizontal and vertical. Move horizontal. These will be number values that are returned to these floating point variables, right? So then they're used down here, and in this case, I wanted player ship movement, my RTPC, to be a combination of the addition of move horizontal, the sum. There we go. It's been forever since I've taken math, so I'm like looking for words that describe math values, and to actually describe it in a way that makes sense. So there we go. The sum. We want it to be the sum of move horizontal and move vertical. I can do math, I just can't talk math. Hopefully that's okay. But it's, again, AK Sound Engine Wise, set the RTPC value of player ship movement, in this case, to the combination, the sum of move horizontal and move vertical. So I've even described it here. Set-wise, player ship or is movement. Oh, that's what it was called originally, before I just did movement in general. RTPC value based on the ship's horizontal plus vertical velocity variables. So this, when you go back here, and then go back into your audio, and then your player engine, what I did, how I made this sound like anything, because you're getting a variable somewhere between 2 and -2 at that point to the RTPC. So how this actually works on anything is you go into the EQ and then into the RTPC, and then I've got the band 3 frequency, which in this case is band 3 is my low pass. So I'm changing the variable, I'm changing the value of my low pass based on the RTPC, and you'll be able to hear it here. Let's see if this works. Hopefully it doesn't crash and burn in my face. I didn't test this a minute ago. So we've got, again, the sound there is playing. What you're hearing is the distortion. It's not actually the engine cracking up. It's just random distortion. So, but then if the player moves, he moves. So in this case, it would sound something like, you see how that, like, if I'm trying to cheat it, but that's what, if I move right, or if I move left, or up and down, you imagine yourself hitting keys, you know, and it gives a little bit of something to this sound. So it just makes a little bit of movement happen. So I wanted to also add a little bit of interesting variation if the player moved vertically or up and down. And in this case, I wanted to change the distortion of what's on the sound already. So again, I've got this parametric EQ. Let's see if I can bypass this. Bypass. There's a switch over there. Bypass. So let's just hear what the actual EQ with the RTPC sounds like without the distortion. So you got that really low rumble. It's a lot cleaner. So essentially that's just the low pass filter going up and down. But it adds a little bit of an acceleration movement to it, right? So I wanted to add some interesting breakup of the ship engine, which in this case, let me actually go back to the EQ, turn on the RTPC, press play. So give you something you can actually hear. It's breaking up a little bit. Right, it gives a little bit of life to what a ship engine actually sounds like. If you think about something that's on a landing pad, there isn't just this straightforward hum. It's like there's some kick to it. There's some crackle. There's some fire underneath a ship engine, right? So that's what the distortion's doing for me. So I wanted to add that if we're going north or south, if we're going vertically, I wanted to feel like you had some thrust underneath the ship engine, right? So So this is what we're doing again for the game scenes, for the player ship vertical distortion. So I'm just have a very easy range, very, very light, a -1 to a 1 with a default of 0, a center of 0. So if I go back into the code, and I go to aksoundengine.setRtpc vertical ship distortion, or player ship vert distortion, it's just with the value of move vert. So move vert can either be up to 1 or down to -1 if you're going up or down. Then my note is Wwise player ship vertical distortion RTPC value based on the ship's vertical velocity variable. But this is the exact same thing we've just done twice. So this feeds me a number value of whatever move vertical is, and it's only going to be between 1 and -1 with a default of 0, which means no change at all. And then we'll go back to the audio, back to the player engine, then to the guitar distortion, and then the RTPC on the guitar distortion itself is here under distortion drive. It adds a little bit of drive to it. Again, if you wanted to add an RTPC, then you click this button, and this is whatever you're trying to, let's say I wanted to add more output gain, right? And then I have a game parameter, and I'd have to put a new one in because I've used all my game parameters at this point. But you can do anything, actually, yeah, there we go. Here's all your game parameters that I've defined within the game, and you can do output gain based off of any of these game parameters. There you go. That's how you add one. So I'm actually going to remove that because we don't need it. But the distortion drive then does this. Let's see. Hit play. And then when you go vertical, very, very light and almost unnoticeable, but it's there, trust me. You don't really hear it because it's so damn subtle, at least in Wwise. But I can tell when you're moving forward in the game. It's hard to do because you can't actually play with both of these variables at the same time, both of these RTPCs within Wwise. But when that ship kicks forward and you have the EQ change and the distortion change, you can actually very clearly hear it. So, but that's the walkthrough of all of the more complicated RTPCs on the player ship, and I've again described panning to you. So you should be straightforward on how to do all of that at this point. And now you know why I've added a parametric EQ with a low pass filter and the guitar distortion on the player ship, and why I have those things set the way that they do. So, got any questions? Hit me up again, Twitter at Adam T. Croft, or comment below. I'll be back. The last of what we have to describe on the Wwise Unity walkthrough is music. Music. The sound of music. So we'll have, just to give you a little bit of a heads up on that, we'll have 3 pieces of music. There will be an intro, a normal, just regular sound that loops itself, and then a sound, a music that loops itself when there's more than, I think, 5 enemies on the screen. So you have a basic and an intense, and then you have an intro loop too. So I'll be walking you through those, and then through the RTPC and this. I don't remember. I guess it was states. I think I used states to set all of the values for the music, and then did it through code. So I'll show you the music itself, then the states and how you set them up through code, and then I will be showing you the beginning product with no sound and the end product with sound, and that will be it. And we'll be done completely with Wwise and Unity, and how to set them up, and how to work together, and how to make sounds in 2D, which is awesome. I hope you guys have enjoyed this so far, and I will see you again tomorrow.